Thank you, guys. That was great. I'd like to introduce now Shiv Sikand. Shiv is the Vice President of Engineering at IC Manage. He was founder of IC Manage in 2003 and has been instrumental in its achieving technology leadership in this category of design management. Prior to IC Manage, Shiv was at Matrix Semiconductor, where he worked on the world's first 3D memory chips. While working on the MIPS processor families at SGI, Shiv created and deployed a script called CDSP4, which was one of the very first design management tools ever created. This tool was later open sourced and provided the inspiration for IC Manage. Without further ado, Mr. Shiv Sikand.
I think what the trends that we're seeing really that the architecture and technology of design management is working on now is that we're moving away from doing monolithic ICs. I think it's fairly well understood that we have to be able to reuse our blocks effectively and to be able to assemble them together. And as the folks have pointed out, you could have multiple different versions of different IPs, and they may have different characteristics that you want to track on them, whether they should be blocked because they have legal issues, or they have revenue issues, where they're restricted for use because of ITAR or other things like that. But also when you start putting these things together, you want to have a very dynamic flow between IP producers and IP consumers. And having a very static flow where the IP guys say, okay, this block is done, and then have to go through another set of steps, which is packaging, which they say is somebody else's problem, makes it very hard to use IP. So the ability to track state and other metadata information that is not just simple version information, but what's the status of it, what are the bugs with this, what tests has it passed, what qualification has it been through. You do that dynamically. So every time you run a piece of verification, or you run a check, or you run some analysis, you can use that information to annotate it back into the database, and then use that to further select and refine and improve your processes. The top two challenges really is all about reducing overhead, right? Some people will say that DM itself is the overhead, and the goal is to make sure that the tools work and scale, particularly for the large data set sizes, both for local and remote. People spend a quarter of their time on DM-related issues. The key is to make that more effective and improve bug management and IP reuse. And then, of course, making sure, as Jacob and others have mentioned, that it's about tape-out confidence, knowing exactly what you got, particularly when you're spooling very, very fast and you're spewing these chips out, continually trying to hit very aggressive foundry schedules so you can get them back. So the best practices that we would recommend, the top one I would say is link your IP repository to the bug tracking system right from the beginning, because bugs and bug fixes are actually represented in your data itself, and that binding is very important so you know what you've got. Use an assembly methodology to capture your design dependencies. When you put stuff together, use a methodology that assembles them. However you do your hookup, how you bring in your different releases. If you do that in an ad hoc manner, or you do it through random scripting, you're not going to understand your dependencies. As a result, you're not going to know what you have in your chip, and you have to backwards figure out what was in it. So you really want to use a top-down approach. And then, is to create your IP derivatives using virtual referencing or, branching, so that you can track and figure out where everything went. So the key to doing that is that when you use virtual copies, you can, understand where everything went. So if I reused a block in 6 different chips, I have a record that simply I can get a report and I know exactly where it went. I don't have to go in and open the schematic or open the, the RTL, or even on the fib machine try and identify what the layout or PNR of a particular block looked like. And we've all done that. So the key is to, is to get away from it. And the bug dependency tracing is that when you put together lots of IPs, you'll know that when you assemble them based on their available releases, you want to get a roll-up report for all the different pieces in it. We want that to be computed, not generated by someone going through a spreadsheet. Okay, so it's utilities to handle that. And then finally, for dealing with virtual file distribution, is the ability to accelerate your EDA tools to eliminate bottlenecks and to maintain workspace control and stability. The measurable results that we're seeing, real-time data exchange, you're saving scales with the number of engineers, you have maximum compliance with your internal procedures and flows, and finally, time to market through project time savings.
Thank you, Shiv.